All right, I was looking for the little button that says recording has started, but I did tell it to start recording, so we're going to hope that that's happening. And welcome everybody today to our continuing education webinar about climate change in North Carolina. We're really excited to welcome Rebecca Ward, who's going to be presenting today. Excuse me, Rebecca is an assistant state climatologist for North Carolina. She works with research in North Carolina's climate and working with various sectors in the state to understand, educate, and communicate about climate-environment interactions, including climate change. And Rebecca has a bachelor's degree in meteorology and applied mathematics, as well as a master's degree in atmospheric science, and she is currently working on a PhD in science education, and these are all from NC State University. So we're so excited and happy to have you here, Rebecca, and really appreciate you coming to share your time and knowledge with us. So I'm gonna stop sharing my screen and turn it over to you.
Great, thank you so much. I am very excited to be here today. So let me get my screen sharing going. I just tried this out. All right, do you see my presentation slides up?
Yes, yeah, that looks good.
Great. Great, so I have just kind of a high level overview presentation today talking about climate change in North Carolina, really focusing on findings from the North Carolina Climate Science Report, which was released in March of this year and then had an update in May. I did want to, before jumping into that, just talk, a little bit about, myself, where I work in the state. I'll do a quick, just kind of, what is North Carolina's climate like, which I think everyone here probably is pretty familiar with, but just kind of a way to set the stage, and then jump right into the climate change report. So a little bit about where I work. I'm at the State Climate Office of North Carolina. We are a university center, a public service center. We're located at NC State University. If you've ever been to NC State, we are on Centennial campus and are actually in the same building as the National Weather Service in Raleigh. So it's kind of a cool co-location going on. We have three key areas that we focus our work. Research, we research applied climate and environment interactions in the state. We do extension and education, kind of like what I'm doing today. I also do a lot with K-12 groups, just kind of going out and talking to the public. And then we also do monitoring. So we have our own weather network. So this map that I'm showing here, I think I took the screenshot sometime this spring, kind of one of those last days where we had some really cool weather. Each one of those locations you see is where we have a weather tower that we're recording data from a whole suite of different sensors every single minute. It's very high quality data, and we use it for a lot of our different research projects. So that's our website there. If you ever want to learn more, we are in the process of building a brand new website that we hope to launch sometime early next year. So the area of work that I do is kind of underneath this umbrella called service climatology. And so I try to visualize it. This may not be the best visualization, but just to kind of say exactly where I'm coming from. And that might help, if there's questions that come up later and I'm sort of fumbling with an answer, just to kind of give you where my background is. So we think of kind of this traditional setup between the hard science on the left of the screen here. This is kind of what you might think of the classic picture of a climate modeler or researcher sitting in front of their computer. They're looking at data. And then on the other end, you have just kind of the general public, anybody who might have a need for or use for any sort of climate information. And so where I work is in the middle. So I work in this, what we call a boundary space. And so what I do a lot of times is I do my own research, but it's always of this very applied nature. How can we take new cutting edge research about climate and really make it usable and useful for an end user, just somebody who just is not a climate scientist themselves. I also do a lot of going out and talking to different groups of people. I was doing more of the actual going out and talking before this year, But trying to understand what are those needs that people have when it comes to climate, what are the questions, and how can we help make that a research priority. So that's sort of the space that I work in. All right, so moving on from here, I want to just do a quick overview of what exactly drives our climate in North Carolina, and then we'll go into climate change. So the key things that drive our climate really come down to our geography. And if any of you have ever seen a talk from me, this is a pretty common slide that I like to show. So location is really important when it comes to what drives the types of weather that we see. So our latitude, we're situated at about 36 degrees north. This means that we have a temperate climate. We have warm, humid summers, generally pretty mild winters. We do have some shoulder seasons. To our west, we have the Appalachian Mountains. These protect us from the intensity of a lot of the weather systems that move across the country. So you have these big, cold fronts and warm fronts and mid-latitude cyclones. They come across and they kind of get just sort of squeezed a bit and torn apart just a little bit by those mountains. So we will still see the like a cold front come through, but it might have lost some of that intensity. And then finally, the proximity to the Gulf of Mexico and the Atlantic Ocean. This is why we are so humid. This is why we have such a wet climate. We see precipitation all year round. And it's really because of these two sources. Our temperatures, like I said, we're in a temperate climate. We do see quite a bit of variation over the course of the whole year. Typically, we'll see our highest temperatures in mid-July, and typically we'll see our lowest temperatures in mid to late January. This is typical. This is very much a smoothed out line on any given year, right? We're going to see quite a bit of variation from one day to the next. But we can see this. I just pulled some graphs from the National Centers for Environmental Information. This is for Asheville, North Carolina, a 30-year average of where those temperatures are for every month of the year, the average high, the average low, and then just the average of the average. And we can see that we do, in fact, see the highest temperatures in July, around 80 degrees for the high, around 60 something for the low, and then and here we have Edenton, pretty much fairly similar pattern, maybe a little bit warmer. In terms of how much of the year we see typically freeze-free, and I think that this is based on a temperature of 32 degrees Fahrenheit, this graph and number that I'm showing you here. So we typically see about 212 days if we were to kind of draw a box over all of North Carolina. Obviously, depending on where you are in the state, that's going to be really different. I think I was looking at it and there's like a 30-day difference between kind of places in the mountains and the places around Greensboro, and then like another 30 days once you get to the coast. So we definitely have a pretty wide range across the state, but on average, we're seeing over half the year where we are freeze-free, so that kind of that growing season length. And then finally, just taking a look at our precipitation. If we were to look at the whole United States, on that big map there, this is from, again, the National Centers for Environmental Information. Those cooler greens and blues, the whole really eastern half of the US, and especially the Southeast, is pretty wet relative to most of the US, and then kind of just zoomed in there on North Carolina. On average, we receive about 40 to 50 inches of precipitation. The mountains, you see the most local variation. So depending on which side of a mountain you're on, you'll either see the kind of systems coming towards you and rising air and things raining out, or you might be on the leeward side where things are kind of drying out. You might be a drier spot in the mountains. And then on the coast, we also see a little bit higher, those blue colors. That's due to the sea breeze circulation as well as tropical systems. But overall, we're pretty wet, and we see precipitation the whole year round. It does differ in terms of how it falls. So in the summertime, it tends to be more localized your afternoon thunderstorms. We average about 3/4 of an inch to an inch a week. And then in the wintertime, it's more of these big frontal systems, like a cold front coming through or a warm front coming through. Most of the state will see something. It might be kind of, longer periods of time where we see precipitation, but generally kind of more of that drizzly pattern. And then just kind of visualizing nice, pretty pictures. So we see a lot of weather in North Carolina, lots of different types of weather, everything from sunny days to droughts, to hurricanes and severe storms. So we see a lot, and when it comes to climate change, we sort of have this, the basics of how climate change influences things like temperature and precipitation. But then it's once we start to dive into these specific weather events and types that we really start to get into some of the nitty-gritty of how climate change is and will continue to impact our future going forward. So a little bit on just sort of where we are in terms of our understanding of climate change. So we have a pretty good handle on the planetary scale. We have lots and lots of data that we've collected over the past decades, many, many studies that have been done. So we're pretty good handle on what's happening at that scale. And then even at the continental scale, kind of thinking North America or even US wide, we have a pretty good handle on what's going on. There's still obviously some questions, but we're getting pretty good. The place that we've been really getting to in the past 5 or so years, where there's been just a lot more ability to do research at this level as our technology has advanced and as our understanding of the climate system has advanced, has been at this regional and local scale. So we're really able to now look at North Carolina, not just the whole Southeast or the whole US. And we're also starting to look at some of these compounding factors. So things that aren't just looking at how is temperature changing over the course of a whole year, but how is temperature changing, in a single heat wave, those types of things. So the North Carolina Climate Science Report came out in March, and this is part of Executive Order 80. It is a scientific assessment of historical trends and potential future climate change in North Carolina. And the report itself was led by North Carolina State University's North Carolina Institute for Climate Studies. This is located in Asheville, North Carolina. It goes by NCCIX. So NCCIX facilitates climate-related research across the UNC system and its partner organizations. So they were really well equipped to lead this. The report was prepared independently by North Carolina-based climate experts. Many of them were at NCCIX. Others were from different organizations in the state, including NC State University and the State Climate Office. I do want to say, full disclosure, I did not help write this report, but I have read it very thoroughly, and I worked very closely with a lot of the authors in the report. So the report content is informed by the scientific consensus on climate change that's been presented in the 4th U.S. National Climate Assessment and the 5th Assessment Report of the IPCC, the Intergovernmental Panel on Climate Change. And it takes into account the latest research published in credible scientific journals and information from the North Carolina State Climate Summary. And then just finally, it really is looking at what are the observed historical trends and different climate variables, what are those projected changes in those variables, and then what are those interconnected impacts that we can see. It does consider 2 different future scenarios. I'm not going to go into too much detail on what these mean. If you ever Google, or if you have questions, I can talk about it more in a break. But the gist is that there's a higher emission scenario, which is RCP 8.5. So in this scenario, greenhouse gas emissions continue to increase through the end of the century. The 8.5 refers to the concentration of carbon that delivers global warming at an average of 8.5 watts per square meter across the planet. So RCP stands for Representative Concentration Pathway. And then we have the lower scenario, which is 4.5. In this one, emissions increase at a slower rate, peak around the middle of the century, and then begin to decrease. I did do some searching. I've kind of always been looking to see, you know, which pathway are we on as a globe? And what I found is mixed. And so I don't really have a great answer to say, you know, which one is more realistic for the future. I think at this point, the most I've seen kind of points to the 8.5 being more likely than 4.5, but maybe we aren't really quite on 8.5. Okay. And then finally, just a quick note about models, because this is, these projections do use climate models to project the future. And it's really because we can't do an experiment on the Earth. We only have one Earth. So we create this model that's based on our best understanding of the physics, the thermodynamics, how the Earth works. And then we train the model on past data. We see, can we replicate the climate that we have seen? And then we run it into the future using kind of our best guess of you know, where the emissions will be in the future and what that will mean for our temperatures and our precipitation and other types of factors. All right. So jumping into what we expect to see for North Carolina's futures. All the pictures I'm showing here are from the North Carolina Climate Science Report, and I tried to throw that link at the bottom and even reference just kind of the specific chapter it came from. I will make this presentation available, so if anybody wants to kind of use it as a way to kind of go and reference the report, hopefully that'll be a little bit easier for you. So based on the historical record, we have not seen an observed trend in annual precipitation in the state. However, projections are that the total annual precipitation will increase by the middle of this century. And that's what's shown on this slide. Over the next 20 years, 2021 to 2040, both that low and high emission scenarios project small increases in the annual total precipitation. We're talking 0 to 3% increase in that total. And that's what that map on the left is showing. And then by the middle of the century, the lower scenario, lower emission scenario, is projecting only slight increases, while the higher scenario is projecting about a 3 to 6 increase in the mountains and Piedmont, and about a 0 to 3% increase in the coastal plain. Let's see if I can. So kind of that blue box there is the next 20 years, and then in the red block are the two different projections for the future. So that's kind of just total annual precipitation. But what might be more of interest, and is more of interest to me, is specific events, and in particular, extreme precipitation events. So these are defined as days where we see precipitation of 3 or more inches, which is a pretty heavy precipitation day. So over the historical record, the number of extreme precipitation days varies quite a bit, but there is a statistically significant upward trend in the number of extreme precipitation events over time. So we are seeing more of these. And the highest number of extreme precipitation events have occurred in the last 4-year period of the record, so from 2015 to 2018. And the physical mechanism behind this is that under a changing climate, we have a warming atmosphere. And the warmer your atmosphere is, the more water vapor it can hold. And so it has more water vapor that is available to produce these intense heavy rainfall events. So our projections for the future under both low and high emission scenarios suggest an increase in the number of days. The map on the left showing the higher emission scenario for the next 20 years, while the center and right maps are showing that next 20, or the 2041 to 2060 period, with the lower scenario in the middle and then the higher emission scenario on the right. So there's a virtual certainty that the amount of water vapor in the atmosphere will increase because our atmosphere is warming. And so it's very likely that the risk of extreme precipitation is going to increase everywhere in the state. So I'm going to leave this up for just a second. I inserted my pause slide, which is, we're at 20 slides in. I think I have 60 total slides, not that we're going to take 60 more minutes, but If there's any quick questions about what I've covered so far, if anybody wants to type that into the chat, and we can pause here and answer those, and then I will go on and talk about things like temperature and hurricanes and drought. Can I explain? Oh.
Yeah, I was just going to say there hadn't been any questions up to now, but I dropped the link in. Of course, you said you were going to share your slides, but the question did just pop in about if you can explain the percentage for each of the scenarios.
So I'm assuming that this is for the slide that I have up on the screen right now. So we're looking at a percentage change in the total number of days. So for example, yeah, this is kind of hard. This is where when you throw graphs up from a report, and you should really think more about how exactly to interpret what that number exactly means. So if I was to look at some of these dark blue areas on this one, I would see it as we're looking at an 80% increase in the number of days that we see per year. And so I would take that to mean whatever we have in our historical record, which I don't have the map up for, but we're expecting to see that much more relative to our historical record. And I'm seeing a lot more questions come into the chat, which is great. Let me see here.
Yeah, so there's a question about is the average number of days per year with greater than 3 inches? Is there an average number of days per year with greater than 3 inches? And how much does that increase on the high scenario?
There is, yes. So there is an average, and I did not pull that map into this, which I, in hindsight, realized would have been really valuable to see. So I guess maybe this graph, oops, here kind of shows what the average number of days that we've seen. This is averaged over 5-year periods in the bars, and then the lines themselves are what it was for each year. So here we can kind of see that on average, we're, not seeing, like most years, we'd only see like 1 or 2 days, if that, but we're starting to see that increase over time.
Okay. And we have 2 questions that are asking the same thing, slightly different words, but why is there a difference between the low and high scenario, particularly for Wilmington? Under the low scenario, they're actually going to get more extreme precipitation than the high scenario.
Let's see. Oh, I see that. Sorry, my screen is. I can pull my mouse over here. So I think that this is referring to the fact that we're expecting to see more here under the lower scenario than under the higher scenario. So it could be due to a feedback. Under the higher scenario, we could be seeing things like where we get so warm that we start to see for example, like the things drying out more quickly. And so we might have sort of crossed a threshold where we don't see as much extreme precipitation anymore, because the atmosphere can hold more precipitation, but not to the point that it's actually precipitating. That probably didn't explain it very well. Yeah, I think that it's probably because there's other things going on under this that are sort of making, not to say that the climate might be less extreme under a higher emission scenario, but that we might just not be seeing more or as much more extreme precipitation under that scenario.
And you might be about to talk about the last question we have in chat right now, but is this expected to change due to hurricanes?
Yeah, so there are some expected changes due to hurricanes. My understanding of this specific, when they did these scenarios, was that it was trying to not look at hurricane-based precipitation, but we are expecting to see changes with hurricanes in the future. And that is something I'll be talking about in just a moment. So maybe that'll be a good moment to go back to my slides. There's my pause moment. So I wanted to talk next about temperature changes specifically. So over the whole globe, we've increased by about 1.8 degrees Fahrenheit since the start of the 20th century, and our global temperatures are continuing to rise. Things aren't rising smoothly. We are seeing, one year to the next, there's natural variation. We still have weather and climate variability happening, and then climate change is kind of on top of that. So since 1895 in North Carolina, our statewide temperature has increased by about 1 degrees Fahrenheit. And since the 1990s, our temperatures have been consistently above normal, with 20 out of the last 29 years above the long-term average. And that long-term average going from 1895 to 2018. The summer average temperatures have been the warmest on record over the last 14 years, and the top 3 warmest summers also occurred during that period. So in 2010 was our warmest, and then 2011 was second, and then 2016 was third. I do not, before anyone asks, I don't have the numbers on this summer yet. So all of this is painting a compelling and consistent picture that we are warming in North Carolina. Go forward. Right, so I'll try to leave this graph up a little bit because it even took me a while to kind of orient myself with it. So unlike precipitation, where we have kind of just, there's a lot of different things going on and it's kind of hard to tease out and be confident about exactly how things are changing, we do have high confidence in our temperatures. So what this graph is showing is the observed climatological value for the annual average temperature over the period from 1970 to 2013. This is that black line. It's a climatology, it's not a time series, that line, which is why it's flat. It's just trying to show across these years kind of what was that average. And then the gray line shows the simulated historical annual average temperatures for North Carolina. And this is from a specific data set. It is a modeled data set, but they've trained it on actual data to make sure that they are actually representing what the climate was actually like during that period. And then we get to the red and green shaded areas, and these are projected changes for 2006 to 2100. It starts in 2006 because that's when they ran it to start from. I expect that, as we move forward into the future, we're going to see the start date for modeled projections start to become later than that. So the higher scenario is in the red shading, and then the lower emission scenario is in that green shading. And then the shaded ranges, what do those indicate? It's the 10 to 90% confidence intervals. There can, we could see things outside of this, but this is sort of the interval that we're expecting those changes to actually occur in. So by 2050, which is, I can maybe put my mouse on this, so kind of within here, the models are projecting that the annual average temperature in North Carolina will increase by 2 to 4 degrees Fahrenheit under that lower scenario and 2 to 5 degrees under that higher scenario. And something that I think is really important to point out on this is that for the next couple of decades, really whatever our missions path follows, we're kind of locked into a certain track. And it's not really until after about 2050 that our projections for the future start to change based on what types of emissions path we take. So that's why I probably should have said earlier, all the maps that you're seeing really only have one map for the next 2 decades, and then we look at both emission scenarios for the subsequent decades. It's because we're kind of locked into a certain path for the immediate future. And then so once we get towards the end of the period, the lower scenario projections are for 2 to 6 degrees Fahrenheit increase, while the higher scenarios are for 6 to 10 degrees Fahrenheit increase. And that's compared again to that black line, this base period that we're seeing here. So temperature increases have not so far and are unlikely to be a linear increase. So in other words, today won't be incrementally warmer than yesterday, which was incrementally warmer than the day before that. We still have that climate variability. And there are some ways that we're seeing that manifest. If I can click my slide forward here. Right, so what we've seen is that freeze-free season, the length of that is increasing. So again, it's defined as the period between the last spring occurrence where our daily minimum temperature falls below 32 degrees Fahrenheit and the first fall occurrence of a daily minimum temperature less than 32 degrees Fahrenheit. So in North Carolina, for the period from 1990 to 2009, the freeze-free season averaged about 3.5 days longer than the long-term average. And since 2010, it's been about 12 days longer than that long-term average. And this, what we're seeing here in North Carolina is, it's not isolated. We're seeing that same trend occur nationally with a trend towards longer freeze-free seasons. One of the things that I think there's a lot of research going into this is just understanding false springs, and we might see a longer freeze-free season, but that doesn't mean that we're not going to see warmer temperatures before that last spring freeze. So understanding how is that variability in our temperature going to change in the spring, and what does that mean for our ability to plant things or do planning to know what is that likelihood of seeing once we start to warm up, of seeing another freeze in the springtime, is something that we're still trying to understand how that's changing. Forward. We're also seeing changes in our nighttime temperatures. This is where actually a lot of that warming is happening. So we've seen an observed trend in the number of very warm nights. This is defined as nights where that minimum temperature is greater than or equal to 75 degrees Fahrenheit. So the number of very warm nights during 2008 to 2017 is higher than during any other consecutive 10-year period. And then 2010 set a record with a statewide average of 14, which might not seem like a lot, but that's a lot of, you know, really warm nights where we really can't cool down. We as humans or animals, wildlife, plants even. And so future projections are for increases in the number of very warm nights in both the Piedmont and the coastal plain, but little to no change in the mountains. I can pull this up. So I try to mesh these maps a little bit. So the one on the left is for the next 2 decades, and then the ones on the right, that top one is for the lower scenario, and the bottom one is for the higher scenario. So over the next 20 years, we're projecting, you know, little changes in the mountains, but substantial changes in the Piedmont and coastal plain. These numbers might be kind of hard to see, but this is now change in numbers, not percentages. But we're looking to see, looks like between 4 is kind of this light yellow color, and then 8 to 12 is kind of this slightly darker yellow color, and then there's a few hot spots that we see there. And the reason that we're not really seeing as much change in the mountains is just, is not to say that we're not going to see warmer nights there, just that we're not expecting to see these very warm nights. And then once we get farther into the future, we can really see how this is changing, especially under that higher scenario. We're seeing some localized spots with as much as, you know, a month more of very warm nights, which is quite warm. So kind of the, not really the flip side, but just, you know, the other side of the hand when it comes to warmth is thinking about very hot days. So these are defined as days where our maximum temperature gets, reaches or exceeds 95 degrees Fahrenheit. And this is just temperature, not looking at heat index or apparent temperature. So in our historical record, there has not been a trend in the number of very hot days. But because we are expecting to continue to see warming, we are projecting that the number of very hot days will increase in the future. Because we don't have that trend in the historical record, we can't be as confident in exactly what, you know, our future projections. We can just say that it's still likely that we're going to see more. And so this is what those current future projections are showing. By 2021 to 2040, projecting, again, little to no change in the mountains. This isn't saying that we're not going to get warmer, just that we're not expecting to see more of these very hot days. But in the Piedmont and the coastal plain, we're definitely expecting to see a lot more. And then especially once you get to the 2041 to 2060 time period, we're expecting to see quite a bit more days across the state. Right. And then something that is kind of getting to some of those how things interact now, just not looking at straight temperatures or straight precipitation, but how do these things combine in certain events? So drought being the first of these. So because there's not a lot of confidence in our future precipitation changes, it is challenging to make projections or issue a confidence for future drought likelihood. But future droughts are projected to be warmer than their historical counterparts with a high level of confidence. And that's because we're very confident that our temperatures will warm. And so resulting from this, it's likely that future droughts will be more severe in terms of soil moisture deficits and impacts on rain-fed agriculture and natural vegetation. And then just, what are those types of impacts that we see from severe droughts? From our historical record, and we don't really have to go back very far for this, we do know that severe droughts can increase the intensity of wildfires and lower the availability of suitable conditions for prescribed burns. We do know that we have wildfires happen in the state. We do not need to have a drought to see wildfires, but just knowing that severe droughts can certainly increase the likelihood of those conditions that are conducive to wildfires is something to be really thinking about into the future. And then we kind of get to some other ways that things can work together under certain conditions to maybe increase the likelihood of something. And so thinking again about droughts is, our best understanding of the future is that droughts will be more severe than their historical counterparts. So if we're expecting to see, say more droughts, that can increase the stress on trees, which might make it easier for things like insect pests to move in and really decimate trees if the trees don't have as much natural resistance because they're already stressed by drought. And then that can kill more trees or just make the sort of fuel availability for wildfires increase. So we can have these things sort of work together to compound what would already be, increased in terms of, say, wildfires that are drought. We can have other sort of pressures coming in and making those events more severe. And then hurricanes. There's sort of some areas with hurricanes that we're pretty confident in, some areas that we still have some ongoing research questions. So consistent findings regarding the state of hurricanes in a warmer world are that the strongest storms are expected to become stronger. And then associated with this, medium to high confidence that there will be increases in damaging wind and storm surge, things that we see the damage from those things increase when we have more intense storms. There is less consistency among research studies on how the frequency of hurricanes will change, and then let alone about landfalls or near misses in North Carolina. We really don't know how tracks might change under climate change. It is likely that hurricanes in a warmer environment will produce heavier precipitation. And so while global warming is likely to lead to heavier rainfall events and hurricanes, we don't have any scientific evidence so far that future landfalling hurricanes are more likely to slow down after they make landfall. So we have this kind of picture of expect them to be wetter, expect them to produce more precipitation, expect that we could, if more of those storms become more intense, we can see more of those impacts from wind or storm surge. But we really don't know about their tracks or their forward speed. We still have open questions on that. This is just kind of a repeat slide. And then sea level rise. So over recent decades, the global average sea level has risen approximately twice as much from increasing ocean water from ice melt as it has from thermal expansion. And depending on the greenhouse gas emissions, by 2100, we could see like 1.3 to 2.4 feet, or as much as 2 to 3.6 feet globally in sea level rise. But under whatever scenario we are expecting to see North Carolina be impacted. And one of the ways that it's really showing up, and we expect it to continue to show up, is in high tide flooding. So many areas along the coast, we're expecting by the end of this century that they'll see high tide flooding on a near daily basis. And we have 5 tide gauges in the state with sufficiently long records. I will say I'm not as familiar with exactly how they do sea level rise calculations and projections, but they do in the report have really great graphs and some descriptions of what we're expecting to see. So I did pull this one. This is figure 4.5 looking at Duck, North Carolina. And so the top graph is showing the observed relative sea level rise for 2000 to 2018 in that black line. And then the projected relative sea level rise through 2100, which is that red shaded area. And it's bounded by kind of the intermediate low and intermediate high scenarios, which kind of roughly equate to those low and high emission scenarios. And then on the bottom graph, it's the corresponding range and the number of high tide flood days that we're expecting to see into the future. How many days of the year we're expecting to see high tide flooding. So we can see under higher emissions by 2070, expecting to see every day. Under that lower one, might be getting near to that by the end of the century. And then, it's not just climate, right? We have human interactions with the landscape. I'll try to go through these a little bit more quickly. So thinking about things like the wildland-urban interface, this is if you've been following any of the wildfires that have been happening in the western part of the United States, this has really come up a lot in some discussions on how do we think about the future. It's also present here in North Carolina. So the wildland-urban interface is defined as this area where human development meets and intermingles with undeveloped land, forests, and vegetative fuels. And so communities or homes that are in this wildland-urban interface, they're at an increased risk for damage from wildfires. And something that I didn't know until I started to look into this is that North Carolina actually has more acres in the wildland-urban interface than any other state in the country. And I think I have a nice map up here, which I was not expecting to see. And so just thinking about how does that management, how does how we live increase our vulnerability to impacts that we might see from climate change. These aren't really great slides that I have here, but this is just kind of, again, for reference after the talk today. I did look at some of the questions that came in that were submitted and try to find some sources to maybe help answer some of the questions. So there were some questions on what are the impacts of deforestation on climate change, how can reforestation, or I think it's called afforestation, maybe mitigate climate change. And so my digging, it seems like there's not like a solid answer on do this and you will see this type of improvement, or cut down these many trees and this is the exact type of impact you'll see. My understanding is it really depends on where in the globe we're talking about trees being cut down or forests being replenished. And so I tried to find some articles I thought sort of represented the sort of the complexity of the issue, but maybe still were readable. For the Southeast, it looks like when we reforest areas, we do see some net cooling, and we obviously see benefits in terms of carbon sequestration because trees store lots of carbon, but not a lot of great evidence, or at least consistent evidence on what that means for, say, soil carbon storage. And then also some questions on pollinators. I think, here it's just so dependent on which exact pollinator species we're looking at, which exact plant species they depend on, or how does that relationship work. And so there's a lot of ongoing research here, and it really is going to be dependent on exactly what it is. But I think overall it's whatever you can do to help provide more of those resources in the area would be beneficial. And then insect disease vectors, this is something I'm really interested in as well, just kind of out of curiosity. So I sort of found two articles, one looking at insect disease vectors for humans, and then for trees. And a lot of what I found is that it's so complex that it has a lot to do with human land management. So, just the built environment or urban heat island effects, or do we culturally, happen to leave things out that have more standing water in terms of mosquitoes. So there's a lot of things that really interact there, and it's not an easy answer. So my key takeaways before I have a pause slide again is just thinking across North Carolina what we're expecting to see. Changes, high confidence that our temperatures are rising and that they will continue to rise. We are projected to see more very hot days. Our confidence in that is not as great because it doesn't agree with a historical trend, but our confidence in seeing more very warm nights is higher. Future droughts, we don't have a lot of guidance on how our precipitation will change, but we do, because we expect our temperatures to continue to warm, we do expect that those future droughts will be more severe than their historic counterparts. We are expecting to see more days with heavy precipitation, and we are expecting that hurricanes will produce more precipitation than what we have seen historically. All right, so I'll pause here for questions again.
We do have some questions, and so I think what I'll do, if I'll go back up because there's been some coming in, and we'll start with some of the ones that came in right after the last pause and work our way down. Does that sound good? So there was a question about hardiness zones, and have you seen any projection for how plant hardiness zones will change? I know there's maps out there that show how it has changed just in the last 30 to 40 years, and I'm going to drop a link that shows that in the chat. But how about projections of what might happen?
Yes, and I have seen it, and I cannot think of the URL or the source, but I'm going to make a note so that I can send that out after this. That is something that I think I have seen. So stay tuned, maybe.
Okay, and there was also a request about the links, and so I just want to remind everybody that you're going to be sharing the slides, and we'll send the slides out with the recording, and you'll be able to click on the links from that when you get the follow-up email. Okay, so the next question, let's see. Is about any studies that are going on at NC State, particularly in entomology and plant pathology, that are comparing or correlating climate change and insect and disease appearances, life cycles, and densities. I know I know Frank, Steve Frank, who's our urban entomology specialist, he has done a lot of work in looking at heat island effect, so urban heating on pest populations of trees in urban areas, which is a good simulation of climate change because it's hotter in the cities. So this is what happens with just a little bit of heating in cities. We see big increases in some pests, particularly scale insects. So I was going to mention, I know that's something that's being looked at, and I don't know if you know of other specific studies that are going on.
Yeah, so I do know that there are a number of studies going on. There's actually a really great, I stumbled on this, NC State University put together this series of research into climate change happening just all across the university. And there are a couple of articles in there looking at like mosquitoes under a changing climate. And then looking at, I think, like pests for like more of your row crop type agricultural pests. And I can link to that. I don't remember what the findings were or sort of where they were at their stage in their research, but yeah, it's really cool. So that this is the part that's exciting to me, is that we're starting to get confident enough in things like how are temperatures changing or precipitation changing, for example, that we can now move into what does that mean for, you know, insect pests, or what does that mean for changes to fire activity, things like that. So I'll make a note to share that link as well.
All right. We have a question about what in North Carolina agencies focus on steps citizens, businesses, and government can take to slow down climate change.
Yeah, so a couple of my future slides will show like resources and things, but broadly, so as part of the Executive Order 80, which was the current governor's plan to basically have a clean energy future in response to climate change, each one of the state departments has sort of been moved towards doing more about climate change, and specifically the North Carolina Office of Recovery and Resilience, NCORE. They're kind of I think like the spearheading group thinking about this, as well as Department of Environmental Quality. And so I can include links in this too. I think that we're still sort of moving in the direction of understanding it, and now what do we do about it, and making a plan, but making a plan that is something we can actually execute. So there is a new risk and resiliency guide or plan that's been published. That's sort of that first step in that direction. I'm looking at it from more of a high level, like agency level perspective versus individual level, but I think we're really moving in that direction.
All right, we've got some more questions coming in. I did add the link, I'll just say, for that climate, the hardiness zones, is for the Arbor Day Association. You can see that it shows that most of North Carolina has increased one hardiness zone, so we've gotten warmer in the last 25 years. And there was a question about, will the recording be available for people who aren't Master Gardener volunteers to watch? And it'll be posted on YouTube, so you can share that link. And we have a question about any suggestions about what vegetable plants are more hardy to fluctuating temperatures and moisture. And there's certainly some crops like okra and eggplant, things that are from really hot climates that are going to do better in a hotter climate and are a little more resilient to fluctuating moisture levels. But one of the big things that's being pushed for resilience in agriculture is soils, building organic matter in your soils, because that's really going to help with holding moisture as well as improving drainage. So it's a win-win for both heavy rain and drought. And in fact, we'll be discussing more of that in the follow-up webinars for today, that in October, where we're going to look at things you can do to make your garden more resilient to these changes we're talking about. And I don't know if you want to add anything to that, Rebecca.
No, I was just gonna sort of plug the next one and say I'm hoping to listen into that one to learn some tips myself.
Yeah. So we have a question about what are the chances of increased algae blooms with climate change? And it's from Francine. She said, I was reading about the elephant deaths that are being associated from drinking water with large amounts of algae. So do we think we'll see more algae blooms in the US?
Yeah, so that is something that is of really big concern. And yeah, so when it comes to things like that, we're sort of looking at how drought impacts and increases the likelihood of seeing algae blooms. And then because the conditions that we see under drought are kind of the types of conditions we're expecting to see under climate change to some extent. Usually droughts are associated with warmer temperatures, also associated with less precipitation. which may or may not happen, right, under climate change in North Carolina. We don't know that, but at least in terms of increasing temperatures, what are those relationships with the types of organisms that lead to these toxic blooms, and then what does that mean for health risks in the state? There is a relationship there. And it is something that's being actively researched. I don't know, I cannot speak to the, like, what is that increased likelihood? And then how does that work with things like hurricanes, if we, see more kind of nutrient turnover, or if we see lots of flooding coming into our estuaries or things like that, how does that influence our likelihood of seeing these big blooms that are really high health risk? So yeah, I think the long and short answer is, yeah, we are expecting to see that as one of the impacts, especially one of those ones that really can influence our human health as well as just sort of environmental health. There's also some things I've seen about, maybe not specifically North Carolina, but just thinking about how do our like freshwater, like smaller ponds or lakes, if those get warmer, do things like your like brain-eating amoebas become more, capable of surviving, or just other types of organisms that when we have cooler temperatures or more circulation or more precipitation, they kind of get diluted or can't survive. How is that changing? So not to say that nobody can ever jump into a river again, but just that is something that we're really looking at, those interactions.
Yeah, we had some follow-up posts back to the vegetables where, and I think appreciate people mentioning that tomatoes particularly are affected by those higher night temperatures, which you mentioned, and those high night temperatures are really damaging on vegetable crops because it reduces fruit set and you get more blossom drop, especially on things like tomatoes, but some of the other crops as well. And that there are breeding programs going on, knowing that this is an issue, developing varieties of tomatoes and other crops that have higher heat set characteristics. So some crops naturally have the ability to tolerate more variance, but we're also building that in with breeding work to try to develop varieties that have better resilience too.
Mm-hmm.
And so there's a question about, are there any studies on increased CO2 and its effect on plants? And I know there have been a lot, and one specifically I've looked at in the recent this year has been the effect of increased CO2 on poison ivy. Poison ivy is becoming more vigorous. It's the urushiol, I think I'm saying that correct, the stuff in it that gives you the reaction is becoming more potent, or the more potent form of it is becoming more prevalent in the plants. So it is definitely increasing the growth of poison ivy and its effect of giving us those itchy rashes. And I'm sure you've probably seen some stuff too, Rebecca, on how CO2 is affecting plant growth.
Yeah, I think that poison ivy studies are the ones that I've seen the most. and yeah, and I think poison ivy and its sort of cousin plants. I read something where it was like your more binding plants really like to have that more CO2. Some of the other studies I've seen are looking at how do things like wheat or corn even respond to increases in CO2. Looking at, do they basically become less nutritious or more nutritious, or does the sort of nutrition stay the same? Some of the ones I think, I feel like when I read them, it was that there's concern that they're going to become less nutritious if there's more carbon dioxide in the atmosphere. But I know it's just really active research. Yeah.
Yeah. So another kind of related question is it possible that insects and plants will adapt to climate change? And we did get a question that came in by email kind of related to this for Japanese beetles, and how will climate change affect Japanese beetle populations? And I had found a study that had looked at this very specifically, and it showed that climate change is just going to make the number of days that are just ideal for Japanese beetles it's going to increase the number of days that it's ideal for them to be active and for their larvae to develop, especially in the Midwest. So it's going to change their distribution or increase their movement. And I've seen that for similar studies for invasive plants and especially some of the pest insects, that with climate change, we're seeing them move further north or potentially, alter their current population so they're able to move into climate areas that currently aren't as suited for them. And under that study, and I'll put the link in the chat in a minute, it actually showed some of those projections like Rebecca was sharing earlier under the higher projections and lower projections. And it was really interesting that under the highest projection, like if CO2 increases the most and climate change increases the most of the South actually would become inhospitable to Japanese beetles because it would be so hot, and this was by 2050. So, I think the big thing is shifting where plants and insects can survive. But I think there's a lot of plants and insects out there that aren't able to adapt really rapidly at the pace that climate change is occurring. And so there's a lot of concern about them becoming endangered or extinct. And unfortunately, so the ones that can adapt tend to be the pest species or the more weedy species. So I'll let you add to that, Rebecca.
Yeah, no, I think that sums up really well. Yeah, the things can certainly adapt. I mean, we've seen that happen, over long periods of time. It's just that the pace at which we're seeing these changes are, some species will be able to adapt. Some might get some help from human interventions, right? But yeah, there's for sure going to be some species that just.
Yeah, and there was a comment from Louise that, she said, I expect some insects that have 5 generations per year in North Carolina may have 6 generations per year, and that's absolutely true. So our insects that have multiple generations, they're just active for longer, so we deal with them for an even longer period of time, and they increase the number of generations. In fact, that's one thing that the study on Japanese beetles mentioned, the potential for, in some areas, for them to have 2 generations per year, where we actually only have 1 generation now. There was a question about studies on the increase in fire ants. I've seen some of those, but I don't have anything ready to drop in the chat. But definitely with fire ants, they are increasing their range. They're moving further north and moving into areas that used to be too cold for them, and where they've always been established. Of course, they're just thriving.
I've seen some similar things on earthworms as well. No, yeah, again, nothing that I can drop, but I didn't realize that some, like, not all earthworms, right, are native. I didn't realize that, but that especially like up north, like in Canada, northern parts of Canada, starting to see earthworms appear where they never did before, and how it's sort of disrupting some of the like natural systems in the soils was interesting, and something that I had not thought about, because I'm always really excited when I see any worm in my soil.
Yeah, we looked at that. We have our monthly plants, pests, and pathogen webinars, and in our August webinar, Matt Bertone actually talked about these non-native earthworms, and I agree, that was kind of new to me. There are these planarians or flatworms that eat earthworms that aren't native, but then there's also some earthworms that actually aren't native. Okay, so we got some more questions coming in pretty quickly. Again, a question about, will plant zones be affected by warmth in the future? And Rebecca had said she has seen a map projecting that, so you were going to look up that link, but I had added a link showing how it has already changed. So of course, yeah, with the climate warming and low temperatures becoming warmer, we would expect that change to increase, that we're going to become warmer. So we may now, instead of be zone 8 at some point in the future, we may be zone 9 for some areas or many areas of North Carolina. There was a question further back up, and I didn't want to miss it, about well water. And will well water for drinking be affected with an increase in bacteria and other pathogens?
That's a really great question. It probably has a lot to do with, exactly where the well is and how deep it is, and where does, like, how long does it take the water to kind of get from, rainfall or frozen precipitation down into the well itself. So I don't really have an answer to that, but just to say that, yeah, I mean, our water is sort of all connected, right? So there could be some impacts. I just don't exactly know what those would be.
All right. So, and you have more slides to cover?
I do actually have just
Okay.
a couple more slides. It's probably going to be sort of like, a bunch of links thrown out at you, but maybe kind of to show some of the types of places to go to really dive deeper and explore more, getting at not just information, but maybe actions and types of things. So yeah, I can go through those, and then we can come back to questions for the remainder of the time.
Okay, that sounds good. And that actually addresses one of the questions is, will we have access to how to work towards slowing or preventing climate change? So some of the links you're going to share do have that, will help people understand actions they can take. And of course, our October webinars will be discussing that as well.
Yeah. So I have just a couple of things. I know some of the questions that came in before was, like, where can we go just to learn more, or maybe what sort of our trusted sites to recommend. So I pulled together some things that I really find helpful for like nice snapshots. So one of the ones I always recommend is NASA's climate change pages. I really like it because you get the, like, right up front, how much has our carbon dioxide levels changed? How much has our global temperature changed? And it's updated all the time. So I really recommend that. They also have this really great sort of like fingerprints of climate change, and just, new research that comes up is there as well. And then just, again, these will be made available, but I thought about some like videos or documentaries or podcasts. I am guilty of, I don't watch documentaries on climate change. I find them just really depressing. But I do, I have looked at some things that I think are really valuable. So one I watched recently is called Our Climate, Our Future. It's geared towards youth, but it really goes into, it's about 40 minutes long. It goes into the basic science of it, and then sort of looks at, how can we as a global society, or even as Americans, what are things that we can do to make a difference. There's this series that's been run by the Durham Museum of Life and Science called Climate Conscious NC. They've been doing sort of evening webinars, kind of open webinar sessions, but they're also turning it into a podcast. But you can see, if you were to click on that link, where they have everything recorded. They're short, like 30 minutes, but they're really designed to be just kind of this conversational with people in North Carolina. What are we seeing? And then I was just looking at, I actually cannot, vouch for how good or, worthwhile this is of listening to, but I was just trying to see, what are there, what types of things are there within North Carolina. So I found this from the North Carolina Botanical Garden. I don't know, maybe you, Charlotte, have heard of this before, but it's called a Plant Power. It's a 6-part podcast looking at climate change and plants in the state. So I thought it sounded interesting, and I was going to try to listen to it as well. And then just some sources for up-to-date information, kind of more news type things. So my office, we have a climate blog. One of my colleagues, Corey Davis, does most of the writing for this, but really taking, what have we seen for the past month or past season, putting it into a longer term climate perspective. Also taking current events, if we just see a hurricane or maybe a heat wave, or anything that we see, how does it fit into that bigger climate perspective and climate change. Sea Grant has Coast Watch. It's a periodical that they put out, and they also have a lot of really great new research that's shown or shared in it. It's going to be all kind of coastal focused because it's Sea Grant, but it is really interesting. And then there's another series of webinars that my office is running on climate change, and so we're posting all the recorded recordings to that link at the bottom there if anybody wants to check it out, as well as some related resources. All right, so some things to explore data if you're interested. So one I really highly recommend is the US Climate Resilience Toolkit. And then specifically this Climate Explorer, that link at the bottom. It was built to accompany the toolkit, but I really find it nice because you can dial into your location and you can explore what has your past climate looked like, and then you can explore future projections for a lot of different types of variables for your location. So I really like its sort of like local contextualized information. And then some of the like more what can you do types of things. So the adaptation workbook, it's a climate change tool for land management and conservation. It's designed to provide a step-by-step process to help you consider how climate change might affect your land management and conservation goals. I think it might be geared towards like sort of larger scale than a single like backyard kind of area, but I think it's still interesting and helpful to kind of walk through. But the idea of it is to help you design a custom plan to prepare for changing conditions. And then there's iTree tools. So this is something that I saw almost 10 years ago, but it's really interesting just to think about how can you, planting a tree or a specific species of tree, what are the benefits that you might see in your, in your single yard or in your community, based on things like the canopy, and shade area, or benefits to just the general environment in terms of like water, pulling nutrients and pollutants kind of out of the water supply. So I think it's a really interesting tool to explore as well. And then there's also kind of more forestry centric as well, is the Eastern Forest Environmental Threat Assessment fact sheets. This is less sort of what to do, but might help answer some questions. They have fact sheets on a variety of topics, including like invasive species or how climate and severe weather affect trees and forests. So they're nice starting points, or just kind of like food for thought types of things when it comes to climate change, climate impacts, and national forests. And then, as I mentioned earlier, the North Carolina Risk and Resilience Plan that came out in June. I full disclosure, have only sort of skimmed it so far. It's designed to be more kind of like for state agencies and organizations to think about where do we need to go and how do we get there. But I think it is really helpful, and it's kind of inspiring to me because we're, as a state, really moving forward to actually go from just thinking about the science to actually thinking about what can we do to mitigate climate change or adapt to climate change. And so those are all the resources that I have pre sort of selected to share. And so I guess I can take any additional questions that have come in.
Yeah, I would say I'm really glad you shared that iTree tool because it is very neat, and I had not thought about that. But it just like you showed, it can help you choose the spaces to add trees in your yard where they will have the most benefit. And so I'm going to drop that link in the chat, but there was also a request for the websites, but I just want to remind everybody that we will be sending out the recording, and in the recording we'll have a link to these slides where you'll be able to click on all the links, so you don't have to worry about writing them all down right now. As long as you are on the Master Gardener email list, you'll get the follow-up email, and you'll be able to go back and explore all these links. But there was some discussion in the chat about Africanized honeybees, and some folks had answered back about like many invasive pests, especially those that like warmer conditions, the expectation would be that their range would increase, or that as things get warmer here in North Carolina, it would make an even better habitat for the Africanized honeybees. And there was a good question about, is there an organization that is looking at policy guidance as well as economic incentives to help with cutting emissions?
Yeah, that's a really great question. there are a lot of NGOs that are doing this type of work. Let me take a look and see sort of like if there's a nice, like, I don't know, clearinghouse, if you will, of places that are doing that type of work. Because I think that that is really important to be able to connect with and see what types of things are happening from more the policy side. That's really where the bigger sort of national and international changes that need to happen are going to be from that angle. And so I think that's a really great question.
And there was just interest in the effect on well water systems overall, you know, as with climate change. If you've seen anything especially specific for North Carolina, how changing precipitation patterns and temperatures could affect our well, because I think in North Carolina we still have about 50% of people on well water compared to you know, city or town water.
Yeah, I have not seen any specific studies on North Carolina well systems. I have just, you know, sort of interacting with water supply managers, more your surface water supply managers. You know, they are thinking about how do we ensure that our lakes have enough storage to last us into the future under changing climate and population and industry demands. Yeah, I'm not really sure about our well water supply. I think one good thing about North Carolina, you know, I saw a comment that this was a depressing talk, and I always feel really bad talking about climate change because it can be very, very unsettling, very depressing. I do want to say that I do feel a lot of hope for the future. There's a lot of great research that's being done. There's a lot of, you know, governments and organizations that are really trying to do things. A lot of people, you know, everybody who is here today, right? Maybe we're a little bit slower and late to the game, but I do think that we are seeing things happen. In terms of well water supply in North Carolina, most of our understanding of how our precipitation will change in the future is that it's not going to get drier here, which in terms of well water, you know, recharge and supply is good. In places like California or even the Ogallala Aquifer in the central US, they've been depleted just from more water being withdrawn over decades that outpaced the natural system resupply rate, and then they are projecting that the futures there will be drier. So we're not expecting and we're not seeing those types of impacts here, which is, I think, promising.
Yeah, and you know, I think in order to figure out how to address things, we have to understand the problem, which I know this is the depressing part, is looking at just the data, but that is part of figuring out where to go and what to do. And so there was a comment about the hoping that the data collected by individuals who volunteer with CocoRAS is helping.
Yes.
And
it is, and actually, I'll give a plug at how many people here are part of CocoRAS, the Community Collaborative Rain, Hail, and Snow Network. It's a backyard precipitation observers, as well as a couple of other things like submitting reports to help with drought monitoring, or even things with like soil moisture or evapotranspiration. One really cool thing was that a year ago, I attended the CocoRAS kind of has a conference, and some of the observations, you know, some of these stations have been around long enough now that we can actually use them for our climate records. So we typically want to have about 30 years of data from a single station before we can say, you know, now it's a high quality station. We can actually calculate some statistics on it to understand the climate of that specific spot. And CocoRAS, so citizen science observations, are now being part of these official records, which is really exciting, and I think that we'll continue to see that more and more into the future.
Absolutely. So we have a couple people saying they've heard a talk you gave a few weeks ago and have joined CocoRAS. So
oh, great.
Yeah, and I dropped the link into the chat about CocoRAS, so you can go there. Is there a North Carolina? This looks like a national one. Is there a North Carolina specific?
Yes, and actually, my colleague, somebody who I work with in my office, is one of the co-coordinators for North Carolina. Her name is Darian Bertrand, and I can share the link. I think if you go to the COCORA's website, there is like a North Carolina, like you can click on the states, and then there's like North Carolina. But yeah, there's state level coordinators with COCORAs, and then each sort of like region, I think it sort of aligns with National Weather Service offices. A lot of National Weather Service forecasters do a lot of COCORAs as well.
Oh,
So
good.
yes, yeah.
I think I found that NC link and
Yeah,
put it there.
that looks right. Yep.
Yeah, and there's a question about how master gardeners can get more involved in climate reporting.
Yeah.
Other than COCORAs, are there opportunities for citizen science?
Yes, there are definitely. And I can actually, since somebody mentioned the talk I gave a couple weeks ago, which was kind of more generally on climate, not really climate change. I had a couple of slides I put in there on citizen science projects, and I'll kind of, I can sort of add this to this slide deck. That way everyone has the links. But briefly, yeah, so there's like the Globe citizen science program. It's run by NASA, and it started with how you can, the satellites are looking at clouds, but sometimes they're not great. And so you have basically citizen science observers who are identifying clouds on the ground, which helps bias correct the satellite measurements, which is really great. And that's super important as we understand how cloud cover and cloud types are changing under climate change. There's also a relatively newer program called I See Change. And the Durham Museum of Life and Science is also doing a lot with this too. But the idea behind that is really reporting on things that you are seeing, weather impacts or, changing seasons or phenology, things that may at first seem like they don't really have anything to do with climate change. But as we build this record of observations that are sort of non-traditional, that we can really get a better handle on how local climate is changing. And then I saw you just mentioned Project Budburst. That's another really great one to help us understand how, like, the spring season timing, for example.
Yeah, people can track when things bloom and see the shifting seasons. Those are great. Okay, we had somebody note that iTree doesn't support Mac or the Apple operating system, so that's good to know if you're used to trying to get to it from those. And tip two, there's been lots of great stuff shared in the chat, and you can individually save the chat. All you need to do is go to the where you would enter a message, and you see a little circle with 3 dots in it on the right, and if you left click on that. I don't know left from right. I always have to look at my hands. But if you left click on that, you get an option to save the chat, and that saves it on the hard drive of your device. But again, Rebecca's slides will have many of these links, and I'll also go back through and pull out things to send with the recording, some of the links that have been shared. And I'm thinking as people are appreciate the presentation, compliments coming in. So thank you everyone for being here today and participating. I don't think I'm seeing any additional questions. Just more compliments or more comments about COCORAs and joining, and that would be a good way for Master Gardener volunteers to support this data collection, as well as the other things like Project Budburst. I'll just say, talk to your agent about submitting those hours for volunteer service. So your agent will be able to give you approval to use that time for Master Gardener volunteer program. All right, looks like we're wrapping up right on time, which is wonderful. We really appreciate you being here today, Rebecca, and for the information you shared and all of the resources, and especially appreciate you being willing to share the slides. We often get that request, so that's extremely helpful, and all of the links and information that you will be adding to what's already there. So thank you so much. Any last words or things you want to let people know about?
I just want to, I guess, say thank you. I hope it was informative. And, if you need clarification on anything, or, you go back and watch the recording and you're like, wait, that doesn't make sense. Please feel free to reach out. If I can't answer you, I know somebody who can. So I'll be sure to connect you and try to answer any questions you have.
Okay, and so with the email address up there, the Rebecca_Ward, so that's one thing with our NC State email addresses. When they're automatically underlined, you might not realize there's an underscore mark between our first and last names. So that is Rebecca_Ward at ncsu.edu. All right, well, appreciate you offering to follow up with folks that way. Okay, well, we thank everybody for being here. I will be sending out information about the next set of webinars tomorrow, and we should get the recording out for today and those additional links in the next few days as well. Some other opportunities coming up are the, I can go ahead and share my slides back just really quickly, are the online plant ID classes. I know many people have taken part of those, but there'll be new sessions of those starting in October. If you're interested in learning about plant ID and the use of edible plants, bulbs, and houseplants, as well as there's a course on trees, shrubs, and conifers, you can register now. You don't have to wait, and by registering early, you get early access to the materials. And there are more topics coming in 2021. And there will also be another session of the Introduction to Therapeutic Horticulture course starting in February 2021. The registration is going to open in mid-October. There's a huge waiting list and a lot of demand, so it's going to be first come, first serve. So I recommend, if you are interested in signing up for that course, as there'll be some announcement that'll come out. As soon as you see that, go ahead and register. And the way to get all this information is through our Extension Master Gardener email list. And the link to subscribe is here on the screen. You do not have to have a Gmail email address, but you do have to have Gmail to go in and see the archive and stuff like that. So if you get a message that makes it seem like you can't register with a non-Gmail address, that's not right. Go ahead and submit your email and it will add you to the list. If you have any trouble, you're welcome to email us and we can add you. And I'm going to just drop that email list into the chat really quick. It's our NC EMG program at ncsu.edu. Okay, I think I got that all spelled right. So if you have any trouble signing up for the list, give us an email and we will help get you on. And thank you, everyone. We appreciate you being here and look forward to seeing you and hope you all have a great rest of the week and weekend. Okay.